A big Watto, and welcome to a slightly different Grandad's Top Tips. Um, Today I have borrowed a workshop, if you like, and what I have is, let me just show you here. It is a laptop, an Acer laptop, and it's come in, and the lady who owns it has said it's dead. And I just think this might be an interesting project to film and see how we get on. Okay, so I had a quick look at the customer's power supply, and yeah, that's dead. So I'm just going to find a workshop power supply and check that, and yeah, let's see if that works. Okay, let's just take a quick look at the voltage then. I've got a well, it's just a little pin thing to open up SD card holders. I'll stick that into the center there. Not too fussed about the parity, but actually the center should be positive. Okay, just stick that on there, and oh, there we go. Got a reasonably good contact now, and that's reading 19.18 volts. I don't know if you can see that on the meter. 19.18. Take it off, put it back on again. 19.18. Okay, so that's quite a good voltage coming out of the power supply. Let's connect it up. And the socket is on this side. Right, let me just move my multimeter out of the way and my multimeter stand, which is a heap of hard drives. Okay, let's just have a look. Then normally you would get a charging light, a telltale charging light coming back to the unit. But let's just see if we can switch it on anyway, just out of interest. Move that to one side, or fingers and thumbs. Let's open it up. Again, a massive reflection from all over the place. Apologies for that. So the on-off switch is here. Give it a little bit of a shadow on there. Hold it, and no, it's dead. We've got nothing happening here. So the only option, of course, is to open this up. Let's just take a quick look and see if it's easy to open. Okay, there is a heap of screws on here. We have to take everything apart and yeah, get the crack it open. So let's see what happens. First things first is let's get the battery out. Okay, so that's the battery removed. There are some screws here which need to be removed. But anyway, I'll just crack on, get all these screws out, and yeah, see what happens. I'll be back in a mo. So this is the laptop stripped down. The hard drive's out. That doesn't make any difference for checking the power. Also, the battery's disconnected. The DVD driver is also out. Well, better move that screw from there before I switch it on. So here we go then. Let's see what happens. See if just by removing these items, whether it makes any difference as to whether it's going to power up or not. I just press the on button. Then I've got the screen here. You can't see it, but it is still as dead as a dodo. It isn't going to do anything. So having looked at this, I think the best scenario here is to take the motherboard out completely. Okay then, so this is the motherboard on the bench. Let's just check for some power around about the place. I'm just going to find an earthing point. All of these screw bases here are in fact earth. So I'm just going to check on these MOSFETs here. These are the power MOSFETs. I'm looking for 19 volts. Nothing there, nothing there, nothing there. Oh, here we go. Yeah, so there's 19 volts there. Just checking on the other side of this MOSFET, and there's nothing there. So there's nothing going through this MOSFET. The question is, why? Okay, I'm just going to disconnect the power. Let's just come to ohms. Let's just short this out. And let's just make sure that there's nothing going to earth. Now, no, this side isn't going to earth because I've got a voltage there. Or I did have. Okay. Right. The other side of this particular MOSFET, I've got 500 ohms, which isn't much. I expect to see kilo ohms there. The other MOSFET was the same point, again 500 ohms. And then the other side of this MOSFET, we have got an earth problem. So now the fun starts. I need to see where that other side of that MOSFET's going. I can see it's popping back to the other side of the board. Let me just turn it over. And it's creeping up onto this side of the board. Now I think I've already checked here. Yeah, so I've already checked there. Let's just have a look on these capacitors. There's nothing there. Right, okay then. So we're coming out this side, and we're hitting earth. So I'm just going to have a quick probe around here. Just to see what's happening. Right, okay then. I think I need to do a little bit of investigation. Okay, just doing some more continuity checks around the board. Okay, so what I've done is I've removed this resistor, which is part of the current sensing circuit, just to see where this earth is that I'm getting. So let me just bring the board back in view. Yeah, so we've got continuity. This is where the resistor sits. Okay, that side. So we've got an earth on this side. I'm just doing a bit of hunting around. Nothing there, nothing there, nothing there. I need to flip over to the other side of the board. Okay, now on the other side of the board, let me just see where I need to go from here. So that's removed, that's obvious. That's there. Right, just have a look around. Right. I've removed also PQ11 here. This is part of the charging circuit here. So we've got earth that side. Nothing on that side. Right, I just need to get in close here and just have a look at the circuits, what's left in this little area here, and see what's grounding to earth. Okay, so it looks like now I'm down to 3 possible faults, which they're all capacitors, and it looks like that they are just voltage smoothing capacitors, which is quite handy. I'll tell you why in a moment. So what I'm going to do now is I'm just going to inject a low voltage, say around about 2 volts onto the board, maybe half an amp, and yeah, just go around the board and see what's getting hot. Yeah, so that should be a little bit of fun. Okay, let me just show you roughly what's going on. So it's going to be a bit scatty. So I've just soldered the positive onto a convenient part of the board. I'll show you where that is in the circuit diagram. The negative is, well, that's just put onto a ground point, and I have my little power supply here. So I've set it up for 2 volts. That should be more than enough, I think, at this moment in time. And the current, I'll just show you the current in a moment. I've limited that to, let me see, So there you go, 1.4, 1.5 amps, okay, at a voltage of 2 volts. So I'm going to whack that through the board, and basically I'm going to wait and see what gets hot. Okay, so this is a basic drawing of what's been going on. So input here, little smoothing capacitor into the power FETs, which are arranged into what we call a buck converter. Um, at this point, I measured 500 ohms. Okay, on the other side of this FET, this MOSFET, I was getting 0 ohms. So we had a ground. So I removed R1 and did my continuity checks. This side was high and this side was low, i.e. that was earth at this point. And this is the point where I am injecting my 2 volts. Okay, that's the current running through the board, and all I'm going to do literally is just feel the components and see if I can find something which is getting hot. Now this is going to be a bit difficult to show you on here, so I'm just going to have a touch around to the board over. Okay, just come down here a bit. All right, so I've got the board over. Okay. Uh, ah, right. Okay then. Yeah. Okay. This is yeah. Ow. Okay, I'm just going to switch that off and do a bit more diagnosis. I'll be back in a minute. So luckily, I can't quite determine which one of these two capacitors is actually getting hot. So what I'm going to do is just go and desolder both of them and check them out on the bench and see which one it is. Okay, it's getting a bit exciting now because we may be narrowing down to the actual fault. At this point, I couldn't actually determine what's happening because this part of the circuit, which is the battery charging circuit, was quite complex. So I removed Q11, okay, to eliminate anything that was coming on this side of the circuit. We're still getting a short. I just waited for something to get hot, felt around, okay, and as it happens, it was one of these capacitors here on the charging circuit which had failed. It was short, it was ground. Okay, well, it looks like that might have done the trick. I've just checked the board and there's no short anymore. What I'm going to do is clean up the solder pads where I've soldered on there. So I'm going to put the components back onto the board, the ones that I removed, apart from the two faulty capacitors, of course. Okay, I don't think there's any need at all to put these capacitors back in. They are acting as smoothing filters. So in this particular case, I am sure that it'll be okay. But anyway, let's get it back together and see what happens. So this is quite loosely cobbled together. Let's start off with the power button. Oh, brilliant. There you go. Got lights, and we got lights. We have power. Um, then what I'm going to do now is put together a little bit better. I'm going to put the hard drive back in, the keyboard, connect the screen, and yeah, let's see what happens. But that's looking good. Quite chuffed with that. Okay, so finally, here we go. There is this PC up and running, hopefully. I'll let you know how it goes. There shouldn't be any problem, really. The components that we removed shouldn't affect the function of this PC. So, yeah, I'll get back to you a bit later on. But just to prove to you that this is working, you can see the data transfer light flashing away there. And on the screen here, although we've got a lot of reflection, but hey, there it is, up and running. So what does a capacitor actually do? Okay, let's see if I can keep this simple. If you have an alternating current, okay, that will pass straight through the capacitor. However, a DC current will be blocked by a capacitor. A capacitor will just store a DC voltage. However, in this particular case, the capacitor broke down to earth. It had a resistance, although it would be very, very low. So when I put that 2 volts onto the board, the current took the path of least resistance, okay, and that was the short of the capacitor. So all that current was passing through that capacitor. It made the capacitor get hot, and therefore, by just feeling around, we managed to find out what component had actually broken down. As soon as we moved that capacitor, that took the short off of the circuit, and all was well. And as the capacitor was part of several capacitors which were just being used for filtering, it really didn't have too much effect on the board.